Good morning my dear student. Today we will see the unit cell and the number of particles present per unit cell. There are 7 types of unit cells defined by edge length, that is length of the edge A, B, C, and the angles alpha, beta and gamma. There are 3 types of cubic cells that you need to be familiar with, and these are represented in the figure. Alpha is the angle between the xy plane, beta is the angle in the yz plane, and the gamma is the angle between the xy plane. So let us see the 7 types of the unit cell. Now cubic. Cubic means edge lengths are same. A is equal to B is equal to C, and the angle between the xyz plane, that is alpha is equal to beta is equal to gamma, and it is 90 degree. And there are 3 types of the cubic cell. One is the primitive, second is the body centered, we represent it by the eye, and third is the face centered cubic cell, right? Meaning we will see later on. Then second is the tetragonal unit cell, in which the A is equals to B, but A and B is not equals to the C, while the angle alpha is equal to beta is equal to gamma is equals to the 90 degree. Then it has the 2 types. The P means primitive and body centered. Then orthorhombic having the 4 types, in which A is not equals to B is not equals to C, and alpha is equal to beta is equals to gamma is equals to the 90 degree. It having the 4 types made. The first is a primitive, second is the body centered, and third is the face centered, while fourth is the side centered. These are the 4 types of the orthorhombic. Okay. Then hexagonal in which the edge length, that is A is equal to B is not equals to C, and alpha is equal to beta is equals to 90 degree, while gamma is equals to 120 degree, and it having the only one time, that is the primitive type. Then monoclinic A is not equals to B and is not equals to C, while alpha and gamma is equals to 90 degree and beta is not equals to 120 degree, and it having the 2 type, that is a primitive and the side centered. Next is a triclinic. In case of the triclinic, A is not equals to B is not equals to C, and alpha, beta and gamma is not equals to the 90 degree. It having single type, that is the primitive. Last one is the trigonal. In case of the trigonal, A is equals to B is equals to C, and alpha is equals to beta is equals to gamma, but is not equals to the 90 degree. And the trigonal having the only one type, that is the primitive. Total, if you calculate, there are the 14 Bravais lattices. If you count the unit cell 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and according to that there are 14 Bravais lattices. Now see in details the cubic unit cell, and we have to calculate the number of atoms or the number of particles present per unit cell. Cubic unit cell, the cell is the smallest repeating unit when all the angles are 90 degree and all lengths are equals. 90 degree, not here the Celsius, 90 degree and all lengths are equal. Each cubic cell has 8 atoms in each corner of the cube, and that atoms is shared with the 8 neighboring cells. In the body centered cubic cell, there is an additional atom in the center of the cube, and in the face centered cube cell, an atom is shared between the 2 unit cells along the faces. Now consider the first type of the cubic cell, that is the simple or primitive cubic unit cell. Simple or primitive cubic unit cell having the only atoms or particle at the corner of the cubic cell. And now see how can we calculate the number of particles or atoms present per unit cell. Now this is a formula to calculate the particles present per atom is equals to, that is the total number of atoms in one unit cell, total number of atoms total number of atoms per unit cell is equals to total number of atoms per unit cell is equals to, it is calculated by the formula, that is the number of atoms at the corner of unit cell is equals to number of atoms at corner of unit cell into 1/8, because one atoms at the corner is shared by the 8 other cell, means 1/8 part of a particle is present in a unit cell, plus number of atoms on a face, number of atoms on a face of faces of unit cell into. Now, atom or particle present on the face of the unit cell is shared by the two neighboring cells, means one atom is shared by the two cells, that's why 1/2 portion of that atom present on the face is contributed in the unit cell, plus number of atoms at the center of unit cell, number of atoms at the center of unit cell, number of atoms present at the center of unit cell. According to that, if we by using this formula, if you calculate the number of particles present in the primitive type, then primitive type having only corner atoms present on the corner, and the total atoms present on corner of the unit cell is 8. There are 8 corners and total 8 atoms are present at each corner, and it is contributed by 1/8, plus there is no any atom on a faces, so it is 0, plus there is no any atom or particle at the center, therefore it is 0, and total number of particles present in the primitive type unit cell is equals to the 1, and the coordination number of the simple unit cell is equals to the 6. Coordination number means the one particle is touched or the surrounded by the how many number of particle, that is the coordination number. One is at the top and one is at the bottom. The coordination number of the simple primitive type cell is equals to the 6. Then second type of the cubic cell is the body centered cubic cell. Particles present at each corner of the cube along with a particle present at the center of the body, and that's why it is called as a body centered cubic unit cell. Now if you calculate the particle per unit cell, then by using the same formula, there are 8 particles at the corner and it is contributed by 1/8 in each cell, plus no any particle present on the face of a cube, plus 1 particle present at the center. So total 2 particles are present in the body centered cubic lattice or body centered unit cell, and the coordination number of the BCC unit cell is equals to the 8. Then third type of the cubic cell is the face centered cubic cell. Face centered cubic cell, at the corner of the cube there are 8 atoms are present, plus on each face of the cube there are a single atom present. So if we calculate the number of atoms present per unit cell, then again we can use the same formula. 8 atom at the corner into 1/8 contribution in each cell, plus there are total 6 phases and each phase is having a 1 atom and it is contributed by 1/2 because it is shared by the 2 cell, plus no any central atom, that is why 0. So if we calculate it, then we get the 4 atoms per unit cell, that is face centered cubic lattice contain 4 atoms per unit cell, and the coordination number is equals to the 12. Coordination number of the face centered cubic lattice is equals to the 12. In next section we will see how can we determine the atomic radius of the atom by using the molar mass, crystal structure and density. Thank you. If you like my lecture, then please like, share and subscribe. Plus press the bell icon, so whenever I add the new video you will get the notification. Thank you.